In this section, we will explore the fundamental concepts of OOP and how they are implemented in Python. Let's dive into the world of classes, objects, and powerful paradigm that shapes modern software development. The key concepts that we are covering will be first one, the classes. They are the blueprints for creating the objects. Next, the objects. They are the instance of classes. Inheritance, the hierarchy and code reuse. Polymorphism, multiple forms of an object. Encapsulation, data hiding and protection. Abstraction, hiding implementation details. Method overriding, redefining the base class methods. Data hiding, private and protected members. Multiple inheritance, inheriting from multiple classes. Operator overloading, customizing the operator behavior. Class methods, working with the class itself. And property decorator, controlled attribute access. Classes. The heart of OOP are classes, which serve as the blueprint for creating the objects. Classes define the structure and behavior that objects of that type will have. They encapsulate the data and functionality to a single unit. Here is an example. We define a class dog with a method called bark. This method, when called, will print woof to the console. Notice the self parameter. It refers to the instance of the class and is required for all the instance methods. Notice the keyword class used for creating the classes and the indentation that we have used. Once we have a class, we can create objects, which are the instance of the class. Objects are the actual entities created from our class blueprint. Each object has its own state but shares behavior defined in the class. In the code, here we create an object called myDog as an instance of the dog class that we have created earlier. We then call the bark method on this object, which will execute the code we defined in the class, printing woof. To access a method, we use the object name .method. The inheritance, it's a powerful feature that allows classes to inherit the attributes and method from other classes. With inheritance, we can create a hierarchy of classes where the child class inherit and extend the functionality of the parent classes. In this example, we define a new class puppy that inherits from our dog class. The puppy class automatically has all the methods of the dog, including bark. When we then add a new method, wagtail, to specific to puppies, this demonstrates how inheritance helps us reuse the code and model the real world relationship. Polymorphism allows objects to different classes to be treated as objects of the common superclass. With polymorphism, we can write code that works with different types of objects as long as they support the same interface or method. Here we define a function makeSound that takes an animal parameter and calls its bark method. Because of polymorphism, this function will work with any object that has a bark method, regardless of its class. This makes our code more flexible and reusable. The encapsulation is about bundling data and methods that work on that data with a single unit. It also involves restricting the direct access to some of the object's components, which is a means of preventing accidental modification of the data. In this example, we define a bank account class with a private variable double underscore balance. The double underscore prefix makes this variable private, meaning it cannot be accessed directly from outside the class. This helps to protect the data from accidental modification. Next, the abstraction means hiding complex implementation details and showing only the necessary feature of an object. It allows to focus on what an object does instead of how it does, simplifying the interaction with complex system. Here we import a abstract base class module and define an abstract class animal. With an abstract method makeSound, abstract classes can't be instantiated directly. This serves as a template for other classes. Any class that inherits from the animal must implement the makeSound method. Method overriding allows a subclass to provide a specific implementation of that method that is already defined in its parent class. This is essential for polymorphism and allows child classes to modify the extended behavior inherited from the parent class. In this example, we have a base class animal with a make sound method that prints some sound. Then we create a cat class that inherits from the animal but overrides the make sound method to print meow. This allows each animal type to have its own specific sound. Data hiding is the principle that restricts direct access to objects components. In Python, we use naming mangling with double underscore for private attributes and single underscore for protected attributes. Here is a student class with private attribute double underscore name and a protected attribute underscore age. The private attribute can only be accessed within the class methods like the get underscore name shown here. This helps to maintain the data integrity by controlling how attributes are accessed and modified. Multiple inheritance allows a class to inherit from more than one parent class. This feature enables a class to combine attributes and methods from multiple sources, though it requires careful handling to avoid the conflicts. In the example, we have two base classes A and B, each with their own methods. Then we create a class C that inherits from both A and B, and an instance of C will access to both method underscore A and method underscore B. Python uses a method resolution order to determine which method to call if there are conflicts. Next, the operator overloading allows custom classes to work with Python's built-in operators. By implementing special methods with double underscore, we can define how operators like plus, minus, multiplication and others work with our custom objects. Here we define a point class that represents a 2D point with x and y coordinates. By implementing the double underscore add double underscore method, we can use the plus operator to add two point objects together, creating a new point with the sum of their coordinates. This makes our code more intuitive and readable. Next, the class method and static methods. Python provides special methods that work differently from the regular instance method. A class method operates on the class itself rather than its instances, while static methods are utility functions that don't require access to class or instance data. Here we have a date class with stat class method from string that creates a new date instance from the string representation. The CLS parameter refers to the class itself. We need to see a static method isValidate that validates the date string without needing access to any instance or class attributes. And we use @class method and @static method decorator. Property decorators provide a way to define getters, setters, and deleters for class attributes. They allow us to control attribute access, adding validation or computation when getting or setting values. In this example, we have a temperature class that stores temperature in Celsius, but providing a Fahrenheit property. The @property decorator defines a getter that computes Fahrenheit from Celsius. The @Fahrenheit.setter decorator defines a setter that converts Fahrenheit to Celsius when assigning to the property. This gives us a clean interface while handling conversions behind the scenes. Next, the meta classes are an advanced feature that allows you to customize class creation. They are the classes that create classes, giving you control over how classes are defined and instantiated. Here we define a singleton meta class that ensures only one instance of the class is created. The underscore call and double underscore method is invoked when creating a new instance. It checks if an instance already exists and returns it instead of creating a new one. Meta classes are powerful but typically used in advanced scenarios like frameworks or libraries. The object-oriented programming provides powerful tools for structuring complex applications. By understanding and applying these principles, you can build more robust, maintainable, and scalable applications.